All right, there we go. Good morning, everyone, and a happy Monday. How y'all doing? Okay, we are good to go. Hello Vector, hello ICS, hello Temporus, and hello Caleb. How y'all doing? Buongiorno, buongiorno ICS. Apple's paper. Can you link to the paper? Was there anything exciting? Okay. All right, I might look at that. Fair enough. Right, so what are we doing today? We're gonna chase a bug, and this is not gonna be a fun stream, so I'll apologize up front. Hello, my lady. So, I'm listening to a song as well, and I'm really kind of like half vibing to the song in the background as well. We got Balato ready to play on another screen, but we're not going to do that. Right, so let me show you what the bug is, and what is supposed to happen, and what isn't happening, right? So we can probably get rid of... Actually, I can probably show it through this. Let's skip that. Right. So we're going to start off with step one, where there is no map, as in this doesn't exist. The state is always going to exist. You can't be here without a state. The state might just be a unit, but you're always going to have state, right? So we don't have, we're never going to lack a state. However, this dyne map is really not a dynamic map, right? It is in fact an option of a dyne map, right? Hence the name opt here, right? So says this is optional, but the only type that we're interested in is the fact that it is a map. Whether it's an option map or not doesn't really matter as far as the template is concerned, right? We could be getting this map from another map, right? Saying inner map. That would imply that this map exists, and it may have an inner map, or it might not, right? The result would be a null value return, right? So we have the state, which is composite. We have a dynamic map, and then we have no value. That's because the map is set to none, right? So if we look at the on key press here, this is a very, very nasty piece of code, right? So don't dig too much into this thing, right? But the first thing we do is we check if the map is none, right? So this is an option map, right? So we're going to check if the map is none. And if it is none, then we're going to insert an empty map and then we're going to bail from these things. The first time we press a key here, we are setting the map. And I have done so now, although you can't. Oh, shit. All right, I have to restart that, right? So there we go. Now I set the map. The second time we get here, we check for A. And if A is none, then we're going to insert A, right? So now we've done that, right? That's why it shows 1, 2, 3 there. And then here on the third time, we're going to remove A. And we're never going to get here because we're always going to get here. And right, so we can swap between no value and 1, 2, 3. And this looks correct. This looks like it's behaving the way it should do. However, it is not, right? This should also work. No value, 1, 2, 3, right? But this should also work because if we swap between the map existing and the map not existing, right? So we can do this. So if the map is none, then we're going to set the map, and then we're going to get the map here. We don't really have to do anything with the map. We just have to set it if it's none. So let's look at that then, right? So first time we run this, we should see no value. And we don't. We see dyn map. There is a value there. It's just a none. So that should probably be interpreted as null, right? Hello, Keeney. Hello, Skylam. The map has existential crisis, no doubt about it, right? So let's go through the process of resolving a value, right? So this will become an expression, or rather this entire block here becomes an expression. This expression is known as an either expression. So what we're going to do is we're going to go and debug an either expression and see where that takes us, right? We'll start there. So we should be here, and we can stringify this by saying format first and second. And we can put a breakpoint there. Although that seemed to have done nothing. Is that not recognized as an either value? Ah, right. I bungled this, did I? That's better. All right, so let's look at S1. That is a pending value. It's a composite pending value. So composite is another word for state, right? It's a composite values made up of multiple different values, unlike a map, which is homogeneous, right? You don't care about this. And then we have the key for the lookup. So we're going to resolve this thing and we're going to get opt map out of there. So we're going to resolve the first one. And this is our value. It's a dyn map that is pending. It's a pending map here. But it's not null. So this should probably return null at this point, shouldn't it? So let's see where these things are resolved. Okay, we try this by doing a change to the template, and we don't use that. We use something that does not exist. Okay, if we look at S1, it's gonna go to does not exist. We look at the value, that should be null. It is null. Okay, so why did this become null now? Let's rerun this thing and let's step into this and see what's going on here, right? So this is an index where the index should be the string. And it is. So let's resolve an index, which is a rather complex chunk here with a lot going on. This type info should be composite. That's the first value here. Then we're going to get to the key of this. So we're just going to step through all this. The key should be does not exist, and it is. And then here we're going to do a lookup of this thing. So we're going to do a lookup of this value, and it doesn't exist, right? All right, that's cool. So that is none, and that's how we determine that it doesn't exist. Got it. Okay, let's step into this again, and let's do this from the perspective of having the actual value that does exist. And let's go here. Let's look at the key. Okay, so this value, on the other hand, is not none. This value exists. It's a pending value. It's a pending map. Now, how do we know to resolve this map? That is not the issue, Skylar. If you were to codify the option type, then you could never nest options of options. We haven't even gotten there yet because the type information doesn't fit, right? So we effectively have to resolve this value if it's a pending value. Okay, let's do the same thing given that the map could possibly exist. That would be the same outcome. If the map exists, so now the map exists, but we're going to make the key be missing. Okay, there's the key, which is the op map. So we're going to have to go through this twice. We have another index to resolve. That should now be the map. The map does exist. The key is A. And then we do a map lookup here. And that's what isn't failing. Got it. So the value will be null here, or none, which will result in a null. I don't think we need these anymore. I'm going to clean this up a little. So this lookup will give us an option that exists, but it is none. So that's what we have to deal with. Okay. Let's go one step further with this and let's wrap multiple options then. So this is not an option, it's an option of a map. But that doesn't sit right with me because this should be... Maybe this should have been an option of a value map instead. So if we're going to nest multiple options, it would be option of a value of an option of a blah, 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 right? Before we dive into that, let's see what this looks like if we have a list of lists, right? Let's say that we have a list here that's supposed to contain a list of string. Is that going to be okay? Or do we have to say that this is a list of value list? We don't. So we should be able to do that. What a conundrum, eh? But a list must contain values. So whatever you put in a list is already wrapped as a value. So that makes sense where this would work. However, an option shouldn't work. There wouldn't be much reason to have an option really, but since we already said you can have options, maybe that should be an option value rather than not. That becomes problematic. So maybe we don't want an option then. Maybe we want something else, right? Maybe having something simply being nullable would be the correct way of dealing with this. So instead of having an a value map, we have a value nullable map instead. And a nullable would effectively just be an option. Yeah, I think this might be the right way of dealing with this. So a nullable holds its own in a value. It almost behaves like a map that only has one value, right? But then how would we work with this? Yeah, I think it has to be nullable and not option. Okay, let's look at what a nullable type would look like. We have list in here, don't we? And map. Yeah, so it would be null. And it would be in the value. We could call it a maybe as well. Maybe or nullable. I mean, that is longer, but it would be more familiar. We could just make a type alias. Right. Let's call it a maybe that is generic over t that holds a value t. I think that is the right thing to have here. Now, for this to work, we can imitate what the map is doing. Let's have a none. That has to hold an option though. What has maybe enum variants? What is the commonality for this? Hang on. Yeah. I think Haskell has maybe. Nothing or just. Yeah, that's it, right? I don't want to call it an option because that would be confusing. Hello, Marvin. How you doing? And hello, Caleb. It's the bug that I was working on in the co-working channel yesterday. Like that. Sure are. And then we could replicate this. Just or nothing. Yeah, I don't really want to go down that route. I don't want to imply Haskell. Are there any other languages that does it? And I'm gonna make a pub type nullable. It's a maybe t like that. So you could use either nullable or maybe when it comes down to it. We can have a rather than having an insert, we're gonna have a set function. They do use option, but because option is part of Rust's prelude, I don't want to use option because it's going to be really confusing to have option imported by default and then our version of option. But I think none and some is probably fine here. All right, hang on, let me check. Yeah, that makes sense in the case of TLS because you have variants that make sense there, ICS, but they wouldn't make sense here. We couldn't have plain, right? Now you need to add map. What are you talking about? We have a map. You're literally looking at it, right? Yeah, we can have a map function. Yeah, we're gonna add that. Okay. Yeah, except this is not really an enum. It either holds a value or it doesn't, but there's always going to be something there. We could add a map function. F you, map. Yeah, F you. Okay, so we have a map function now. But we are not quite there yet. This means we're going to have to wipe option from here. Shouldn't map return maybe? No. Map means mapping a value to... Sorry, I didn't mean to sound so short there, right? Map means mapping a value to another value, right? But let me finish this and then we can talk about it, right? Let me go through the notions of doing this. Okay, so then we have the AnyState value here. You know what's really annoying though? I am not a package. F should be F and what? Okay, Skylar, what part of let me finish this? Take a seat, okay? Take the day off, right? So, okay, right. But I don't care what you guys think, so calm down, right? Fuck, what was I gonna say? All right, never mind. All right, we need AnyState for this thing. So let's import AnyState for maybe T. And then T has to be AnyState plus static. Do we need the static bound there? No, we don't. So we can get rid of it here. Okay, so this one, we don't have a lookup function for this. Because we don't have a key. But we need like a get thing for this. So let's have a look at what this thing does. Now the type info is going to have to be the type info of the underlying type. So we have to implement all of this now. That would be T. Ooh, that's... hang on, that's not right. That would imply that we need type info from T. So T has to implement type info. There's no type info. Is it just... It can't be type either. Type ID, there we go, right? And if we have type ID, that means we have a const name type, so we can just do this. There we go. I don't like that flavor very much, though, package. I find it a little bit too sort of flowery, and there's like an aftertaste that is a bit weird. So here's the... Maybe we require this thing to implement T instead. I don't care. No, I don't care when I say that I am trying to finish something and people share their opinions. I don't care about the opinions right then. I can care about them later when I solve the problem. But before I get into a bike shedding competition with the best of you, I'd rather finish this bug today then so we can actually release this at some point, right? Okay. We know what the type is, but where's the option import here? So this one, we have a larger option import for this thing that we have to get rid of now. We have to translate this. That's it, right? Okay, so that is literally what we're looking at here. And that would be the underlying type. So we kind of have to do this, right? And then T is not in any state, but rather a state. Did I take the top one? No. And that becomes a state instead. Is that what we did for the map? I don't think so. No, it's like that. Okay, so... all right. Okay. All right, let's make this work then. We don't have an as ref for this. So instead that would be get. But that's not right. Hello, Yogurt. We are more vibing than vibe coding, I have to say. Okay, let's comment this out and make one of these work. Can we... So where does this implementation come from? This as int. Would that be a map? Maybe. We could implement and then as well. Yeah, it returns an option U. There we go, all right. Right, that needs mutable access to. That's not great, is it? That one takes ownership. We use and then ref instead. That cannot return anything with a mutable reference, I think, right? I think that would be, yeah. So there's no way we can get a mutable value from there. So that's fine. Maybe we make this thing... So is this now chainable, right? We'll try it. We'll write a test for this thing, right? What would that look like? Let's try with just one value here. That should work. Good spelling with cert. There is no toRef for that one. All right, we'll use get then. No, it's as int, you fool. Huh. We don't have that there. Okay. Why would that not work? Well, that one sits in there. Okay. Yes. Is it the other way around? We need the any state? Maybe. So that one should have it. That would be... Oh, why is that not right? Multiple as int found. Candidate one is for states any state for type T. Yeah, so we implement that one, but that one disambiguates itself. Where T is state. So should this be any state then, right? Let's have a look. Should that just be any state? Yeah, that's fine. We don't really mind. Okay, so that one works. And what if we have a nested one? Now that should not work. There should be a maybe with a value. No, that's not right then. No int found for null, maybe. But we are implementing that. So what does this look like when we call as int? We call self and then... Okay, so we need the trait bound. We already have the trait bound there, so that's not an issue. Oh, yeah, you're right. We don't implement type ID. Why is that not mentioned? You are absolutely right. So we need to implement type ID. Well, no, we do have that. Okay, so import type ID for maybe T. Where T is type ID. Okay. I think that was it. Now, what's the map implementation of to any ref? It isn't. We only have state. So this is what's so confusing. Why can we have only the state for that one, but we have to have any state for this? It would be nice if we could do this. But then this doesn't work. Oh, man. Let's see. Does that mean that we couldn't call that on a map? All right. We can't. Okay, that explains it. But why could we call as any map here then? We can't call as any map on this. Wow. Okay, but we should be able to call as any map on this thing. Maybe it's time to get rid of the any state since we have downcasting in the language now. So we could get rid of... maybe we can't. Okay, let's try this, right? Let's see if we can get rid of the any state. Let's do a... We're doing a work in progress commit here. Yeah. And the any state... What does the state look like? It has the type info. So if we say that this thing implements any and static, and then here with our toRef, let's see what the upcasting thing looks like now. Yeah, so we just do self as dyn any. Well, I guess we can just get rid of any ref then, since that already exists as part of being able to do upcasting, right? So we don't really need any states anymore. The type info is fine. Ooh, this could be a little bit grody, I will say. Then that's just a dying state. This is certainly going to cause friction. Oops. Do we have the state already? Yeah. Wait a second, that doesn't work. No state in states, really? Self-loathing, mostly. Oh yeah, I took that out, didn't I? That's the one we need. I mean, why else would anyone be a programmer anyway? Right, there's a lot of static bounds here that we don't need. So let's go back and fix that one as well. Maybe you have to sort of like do a 180 and then come straight back again, right? Maybe that's how it works. Hello, Pepper. I'm trying to fix a bug which has led to new functionality instead. I need to get this finished so we can do the relay, which I am actually looking forward to. That's fine. We can do the 4 state. Now the 2 mute and 2 ref wouldn't exist. I do, Privan. So I think, Privan, I might come by at the beginning of July. How's that look for you? Me and my kid might swing by and see if you want to do a podcast. How does like 1st, 2nd, 3rd July look for you? Yeah, for real. Not really, Pepper, but my kid wants to go to Gothenburg for some reason. So I said, okay, we can go there. And she wants to see Privan's dog. and be on a podcast. So I said, sure. Do I know where Privan is? Oh yeah, man. I got Privan's phone number. I can call him right now. That's not true, but I'm sure I can figure it out. All right, we need to add the theme. Whoops. Vim, please. Okay, start again then. Her dress is bad. Me or Privan? Oh, Gotham. But man, that took me a hot second. Thank you. Thank you for helping me look stupid. And then someone has to say, you don't need any help with that because I know all the good jokes. You. Anyway. Either or both. I will tell my kid that you're Batman, right? But do you have any cameras there, Privan? Because I want to record it, right? I'll bring some camera gear. If you're okay with that, right? Rather than just being an audio podcast. I think it'll be fun to record as well. All right, that's cool. Well, I will give you a shout when I'm there. It's gonna be one of the. I will know soon enough. We're gonna do a bit more planning, but I will know in the next few days, right? Get some BTS. I don't know what BTS is, and a live studio. And I have no idea what it looks like. Whether so Privan knows someone who will let him use a podcast studio. I don't know what it looks like there or anything. So I'll bring a camera and hopefully we can have like we should have 2 cameras, right? Just for editing. It would be a lot easier to edit rather than having to like stop and like change the angle of the camera as well, right? But yeah. Okay, let's see. So this to mute does not work. Why does that not work? Does Dying State not have a to mute, but what has that then? T state value. Is that a value? It's a value. Oh, state is not implemented for box Dying State. That's why. You know, that's going to be painful. We can just find box. We just grab all this code here. It's almost the same. One of these functions does not exist, I think. That's all right. Yeah, to any ref doesn't work and to any mute doesn't work. All right, here is where things gets a little bit tricky. Yeah, go for it, Privan. I mean, if we can't book it, then since I'll probably be there anyway, can just meet up at some random cafe or something for a few minutes and hang out if you want. No, Boxstein trait is fine, Pepper. It's another indirection, like pointer indirection, but other than that, it's fine. So as long as you don't, if you do it every frame on like 10 different things, it's fine. But if you do it every frame on a million different things, you're gonna start noticing a difference, right? So we need to, now the question is if we can actually do this. No, I don't think that's gonna be an issue, Pepper. That's not where your bottleneck's gonna be. Now the question is this type, are we going to be able to cast this? So we do any dot downcast ref or downcast mute to sandwich. I swear I'm getting dumber by the day. Good sandwich. All right, now we just have to implement state for this. Okay, that works. Oh, you need a copy. Okay. There's that copy val function you mentioned, Skylar. I completely forgotten that it existed. I was like, what copy val are you talking about? And they're like, okay, that one, that's there. Ah, the joys of the age. Okay. Oh, there's so many changes here. This is so sketchy. Wait, what? What did we have here? Value is what? Is the option. Where's this val come from? That looks like it's it, right? All right, just do that. No, that one goes straight to as rev because it's an option, and that's dref. That's dref mute, so it should be very similar. That's what we're going for. Okay, this is very sketchy, but we are now changing the MSRV because of this, but that's okay. Well, this is the same thing, except we don't do an expect here, right? So we could just call that beauty. Okay. If you say so, past me. I think you got a bit of a typo there. I think that that inspection needs to be redone, okay, for obvious reasons. There is no way I haven't goofed anything up here. Okay. I want you to read the name of the chair carefully, okay? You know what, Caleb? I'm gonna make that into a command. Made it myself. This is made on a vinyl cutter. They look a little bit like a printer. So you basically get sheets of vinyls and then you have something like this that will cut the things out. That's what I did a lot of the t-shirt stuff with as well. My accountant has one. And she combined with this and we played around with it. And you can do like a lot of really cool things with it. And then you just iron them on. And they sit pretty well. It's a fake one. No, a fake one would imply that this was a genuine one, but it never implies to be a genuine one, right? This is actually an IKEA Marcus. But when you look at this part of the chair, it's so perfectly done for placing some kind of branding on it that I couldn't help myself, right? You have an accountant? Oh yeah, don't you have an accountant, Marvin? Who does your accounts? If you're running a business, someone has to do your accounts, right? You don't do them yourself, do you? Are you some kind of lunatic? Well, we don't have Nullable available yet, so we might as well get that one here. We re-export both. Huh. That's the wrong place. That's where it goes. Get an LLM to hallucinate your tax return. I would be less scared asking my child to do it. You don't mess with accounting. You get that shit wrong, you can ruin your business, right? When the tools do your tag get replaced with LLMs, they will not be replaced by anything unless they can produce actual values. In the same way that your legal system isn't going to be replaced by LLMs anytime soon. Now, I do think we need to change our prelude a little bit. Whoa. Nullabelle. Maybe we should have Nullabelle. This is Lady Nullabelle. Okay. Yeah, I thought so. I believe that. As long as they're poor, that's correct. The accountants don't love accounting most of the time. As a matter of fact, accountants probably hate tax codes as much as anyone else on account of... Wait, why is this thing working? timers there, and oh, it's there. Okay, cool. Because people don't know how to do their accounts, and then they do a really bad job of it. So the accountants basically have to they have to siphon through all your crap because you didn't do it right. Like they'll be end of month, and they get a box of receipts, unlabeled, unorganized, whatever. I do most things myself, but my accountant check things over that I've done it right, basically. Oh, can I see the code, Mad Dog? Because LLMs write really shit Rust code. So can I see it? And which LLM did you use? Fair enough. But they are generally quite terrible. Oh, that's a good one, Skylar. Let's add that. I would be happy to code in an LLM, right? The code doesn't have to be written by me. It doesn't matter, but it can't also not like it has to be good, right? Hello, Doddy. Right, so we run into our first bug here. The type should never change. Three or four, is that it? 209 in value mod. Okay, so I'll goof this up somehow. Yeah, when it can write good code. I haven't tried Claude for this though. Let me see if I have a signed in instance somewhere. All right, so what do we tell it? The classic one. All right, how typical. Okay. That's better. That's better. Okay, of course. Let's see what happens now. All right, it made a free list. Okay, that's not bad, but also, yeah. This isn't bad. All right, this isn't too bad, but you kind of have to know about these things for it to actually be able to produce something good, right? Otherwise, if you just go make a tree, then you have no idea why it's bad, right? Sounds good, Prevan. If you can't get hold of it, then we can probably just go and hang out at a cafe somewhere, right? Why are you writing a tree in Rust if you've already done that? Now, I wouldn't, but the point is, when you're using an LLM to do something, if you don't know how to do it yourself, then the LLM's not going to give you... You don't know if you're going to get something good or not. That's the long and short of it, right? It might give you a value, but that might be incredibly incorrect, right? Right, so why is this thing failing me? Really, I would say it's the opposite. I would say it gives you the illusion of helping you, but that's a little bit like asking your mom to do your laundry for you and then be like, yeah, I do my own laundry. Whenever she decides to come home with you, she's going to be very disappointed. Yeah, you wouldn't be able to know why that first implementation wasn't necessarily efficient, right? So you kind of have to go through the motion of doing this. And here's the problem. If you are new to Rust and if you're new to programming in general and you've never cared about memory. Let's say this. If you never cared about memory layout in the past, you're going to have a terrible time with an LLM. It's going to possibly produce code that may or may not work, but you have no idea if it's really bad or not, right? You might be using Rust for the wrong reasons then, right? That's not to say that every bit of Rust code you write has to be high performance, ultra optimized, super pants fancy, right? Not at all. But if you don't understand the code or why, then what good is it, right? It's like putting a child in a self-driving car and calling them a race driver, right? If it compiles, you have some guarantees. That is correct, Mad Dog. However, you don't know necessarily if the code it produces is really slow, right? Rust has the possibility, right? The bottleneck when it comes to writing performant code is Rust is you, not the compiler. In Python, that could quickly become the interpreter. So you might be able to produce really fast code, but the interpreter can't make use of it, right? In Rust, you are the bottleneck. But if you put an LLM between you and the compiler and you don't understand what the LLM is doing, then all of a sudden you become the bottleneck. Let me give you a very brief illustration, right? So according to the first tree we saw implemented by Claude there, it would use boxes to store the nodes in them and the values inside the nodes, right? Given a chunk of memory, right, we might store a value. Let's say that this is our beautiful memory now, and that for some reason we have a bit of perspective going on here, right? All right, I'm not gonna bother being too accurate here, right? But let's say that this is our memory, starting from here, going all the way to here, right? This is the end. EOM, right? End of memory. So you store a box here, you store a box here, you store a box here, and you store a box here, right? Like you don't know where the memory is stored, right? But if we have a chunk of memory, we're not going to draw out all of that again, right? But we store it like this, right? And then we store the value here, then we store it here, then we store it here, and then here. Now, if the memory is small enough, we can fit all this memory into one cache line. There's one hit where the CPU goes from L1 cache to L2 cache to L3 cache, and then all the way back up again, and then into the register, right? So what exists here in L1 cache is now this entire segment of, say, 64 bytes of memory, right? So when you want to perform an operation on 4 consecutive nodes, they're already here, right? So you're going to do an op, and then you're going to load the value from there. Then you do another op, and you can get the value from there, and so on and so forth, right? If we're doing it this way, then you might be making that journey for every single node that you get, right? Let me just wipe all this out, right? So what this memory looks like is first we're going to go to L1, to L2, to L3, get the memory from main memory. Right? So that's your RAM basically, right? RAM. So into your RAM, and then we get the first node going through here, right? And then we perform an operation on this thing, right? So there's our op, okay? Then you're gonna use it on the second node where you have to make the whole trip again, right? To main memory and possibly evict new things from the cache, and then back up again you go and perform the operation. And you do this 4 times, right? There's a, look like a timing table for L cache access, including main memory, right? I'm sure we can get an image for this thing, right? All right, and not to mention the cache misses incurs for penalty as well. Right, so a cache miss of L1 is 40, L2 is 10, and this is all compounding, right? But this is not really. I was hoping for us to see like a basic table. Someone made a table for that some time ago, and if you think about doing that a lot, because of the boxing, it can place the node anywhere on the stack, right? So if we do this, right? If I have an array of values, they're always stored on the stack unless we move them to the heap intentionally, right? So an array of values are stored on the stack, right? 1, 2, 3. This is our array on the stack, right? If we put a vector on the heap, we can store more things in there than what we can do on the stack, because the stack frame is, or stack space is smaller than the heap space. The heap space and the stack is definitely the same memory, but well, that's a different story, right? So when I put something in a vector on the heap, I am storing this thing in what's called contiguous memory, which means they're stored together. So when I push a value to a vector, if there is not enough room to push a vector to the vector, then I have to take all these values and move them somewhere else with more space, right? But the key thing here is that everything is stored contiguously, right? So from the first pointer to the first value, you add the pointer, the size of the value plus the offset in memory. You don't do that. The Rust does that for you, right? When you go to the next one, when you iterate over them, you're just basically jumping the pointer to the next value, right? And everything can be stored sequentially. Now, when you box a value, let's say you're doing something like a linked list or whatever, right? Then you have all your memory, and a box just means place this thing, whatever this is, on the stack. Sorry, on the heap, right? So whatever we have in here is going to end up somewhere on the heap. But one box is not related to another box, right? So this box ends up here somewhere, right? It's not really a cost to jump from one location in memory to another location in memory per se. It's just an offset, right? But you have to do all the jumping, and you don't write a program that simply just reads from main memory, from your RAM, right? That is not that's not how the computer works. It will take that and put that into the CPU cache. We're talking about your mainstream architecture, your average desktop computer, right? Not some embedded thing from 600 years ago, right? So give you a normal 64-bit architecture, whatever desktop you have, right? You load memory into the L cache, right? The CPU cache. And the further down you go, the slower the access gets. And if you have to go to main memory, it's really slow. And if you have to go from main memory to hard drive, it's an eternity as far as the computer is concerned, right? If we were to translate this into, this is hyperbole, right? But if we were to translate this into like human times, it's like the difference between waiting a minute or two versus waiting several days if you have to go to read things off disk, right? Like it's proportionately insanely slow, right? I wish I remember what it was, what that thing was called that would show this. computer latency graph for L cache, CPU for CPU cache, main memory, hard drive, IO network. There's like one of these things is gonna have this. But it is like, it is, oh, here you go, right? 1 to 2 cycles, 50,000 cycles. That's like, it's disproportionately slow, right? Or it's insanely slow. So when Claude gives you some code, if you look at the code that you understand and go, all right, so what you've done here is you've taken this away from me and you've placed me here, right? You've made my code 300 times slower, so I'm gonna fix that. But if you don't know about this, then you're just gonna go, okay, this is fine, and then your code is slow, possibly. I'm not saying it's guaranteed to be slow. If you box 2 values and you use them all the time, it has no bearing, right? You're not gonna notice any latency, most likely. But if you're storing lots of values and you're going to perform lots of operations on this value, let's say you have a massive tree with millions of values in it, and you're going to be jumping around accessing these values, when in reality what you want to do is you want to go through every value in the tree and change as part of an operation. It's an operation you do frequently. So storing the stuff together in memory makes more sense there, right? But again, Claude's not going to tell you about this, and it would just be, you'd be non-divisive. You get Rust code that might compile and work, and the safety guarantees are there. Hopefully it didn't do something stupid, so the safety guarantees are there. There's no unsafe, maybe. I think what would be more interesting is this. Let's bring up Claude again, right? Let's go to Claude.ai, and here is where where I'm gonna share my ignorance with you, right? All right, so let's see. Write a tree in Rust using unsafe and pointers. All right, so we should be getting a bunch of. All right, so it's basically done what it did last time, but okay. Let's see if this thing is sound, right? So if I try to access and dereference one of these nodes and it's null, then I'm gonna have undefined behavior, right? We start by setting the root to a null pointer. So the root is now incredibly dangerous to dereference, right? So let's just see if we can get the root out of the tree. So we check it for null here, and if it is, then we insert a node. Otherwise, we do an insert at. Let's see what insert at does. Okay, so at this point, I'm starting to get a little bit, all right. Ooh, drop. Okay, it does check if the node is null or not. Okay, got it. But now none of these functions are public, right? So let's say make the fields of the struct and the functions public, because you want to be able to use this outside of the module it was declared in. All right. All right. So that's public. And now the €1,000,000 question: is this code sound? If you didn't know to ask that question, you might believe that this is fine, right? So double free data races dangling pointer. Okay. Where is a possible dangling pointer? You know it, I know it. It's the root node, okay? It's a nullable pointer. It's not a dangling pointer, right? We can ask this though. Okay, so yeah, I'm not gonna play with it anymore. But the point is, if Claude could provide sound Rust code, if it could sanity check your code, that would be great. If it could tell you why ordering relaxed is not a good use in some situation, right? You can say, oh, look, you're basically building a lock, don't use relaxed, okay? If you could do things like that, then that's great, right? I'm all for it. But again, you kind of have to know how to program and what happens, right? Would it make the same mistakes in C? I don't know C, so I can't really... I don't know C well enough, so I can't really do a proper evaluation. And C doesn't offer you the same safety guarantees. So if you're given a pointer in C, that's up to you to make sure that the pointer is fine to dereference, right? There's no guarantees that C is ever made, right? If you produce undefined behavior in C, that's a you problem. That's not a language problem, right? In Rust, that's a language problem, right? Because the language is designed, amongst other things, to prevent the unsafe stuff, right? The memory issues, right? You can barely code JavaScript and people are trying to trust it to code Rust. AI is going to give you garbage too. But the thing is, a tree generated with unsafe Rust. Okay, let's just throw this in there again, right? Let's just do one more, right? And then we say, make a tree in C. Now, it should do something that looks similar to our our unsafe tree we had in Rust. But this is perfectly fine. There is no visibility qualifiers here. There's no public, private, pub crate, anything in C, so you're not going to get those guarantees, right? What I'm trying to say is C never promised you the world. Rust does, to some degree. C doesn't have the visibility qualifiers, and more importantly, C was never positioned as a language that was going to be safe. So the issues that you get with C, and again, like, you are gonna possibly get the same issues when it comes to memory access and performance, right? That you might do, right? I mean, I have no idea where these nodes live. They're not boxed, so they could theoretically live on the stack. I don't know, right? Well, here we malloc, so I'm gonna guess not. And since we just malloc the node, this already tells me that we are not storing the memory like grouped together, right? I think somewhere in between would probably be Sing, right? Where you could have your allocator. Sing is more prone to give you contiguous chunks of memory because of your choices of allocators and stuff like that. It's a bit more obvious there, right? It's sexy though, yeah, but I mean, I can't even, JD. I was going to make a terrible joke, but I can't even. Okay. In C, you can live wherever you want. Yeah. So for better or for worse, right? C never made any promises like Rust did. So I would say C code generated by an LLM, I would trust more than an LLM that generates unsafe Rust code, because the unsafe Rust is a lot harder to get right than the safe C. I said this a million times, but for those of you who are new, C code would be... You can't say that C is like unsafe Rust, because C doesn't have any guarantees whatsoever that Rust has. And even if you write unsafe Rust, you still have to uphold the variants that safe Rust is promising you, meaning if you were to get... So you can do something sort of dodgy here, right? Let's just panic in here and I'll show you, right? So let's do something dodgy here, right? So what we're going to do is we're going to get a string, then we're going to get a pointer to the string, right? Const, so we get a reference to s as a const string, right? Well, we can write out string here, okay? But then I can cast this as a mute string, a mutable pointer, right? And I can do this again, and now I have two mutable pointers to the same thing. There's nothing wrong with this so far, right? Because I haven't done anything with it. But if we jump into the world of unsafe now, right? Having a pointer is inherently safe. There's nothing wrong with having a pointer, right? It's a bit of provenance and an address, and that's it, right? I mean, we've already done some right here, but again, it's not really a UB situation until we get here, right? So we're gonna dereference pointer 1, as a mutable string reference, right? We've already violated one thing here, right? Really? Really, really, really? Okay. Okay. Well then. Well then. That's new, I think. Okay, there we go. So now what has happened is that we have dereferenced 2 pointers. We have 2 mutable references to the same memory, right? Which is why if you have a function called pointers and you get a mutable string pointer and a mutable string pointer like this, you don't know if these are pointing to the same memory, right? Where are you? So you might think that this is fine, right? But it really isn't. The reference, all right, unsafe. It didn't help that we had an unsafe block wrapping this function, right? So, because we could call this thing with pointer 1 multiple times, right? Call pointers with pointer 1 and pointer 1, right? You don't have to uphold these variants in C. This would be perfectly fine in C to have pointers to the same memory. There's no such thing as mutable whatever in C, right? Everything is mutable. So immutability is not a thing. So when you write unsafe Rust, there's a lot more rules that you have to adhere to get it right. And if we maybe if we take this function here and we could try to ask Claude, right? We'll do another run, then we're gonna get on with it, right? Can you tell me if this function can exhibit UV? All right, and obviously it should say yes. But let's see if it can tell us why at least. Yes, points to the same memory. Creating 2 mutable the same violates Rust aliasing rules, even inside unsafe block. Okay, so it got this right, and that's pretty good. All right. Okay, let's see if we can gaslight it. Now, this would effectively not make it any safer. Right? This, you can't have a mutable reference to this thing, right? So if we try to coax it down and say like, sure, buddy, right? Like, is this better then? It should say no. It's safer in practice since A and B points to different location. I mean, this is so untrue. There is nothing that made this better, right? There's no part of this that is better. I'll show you why, all right? So we're calling this with pointer 1 and pointer 1 again, and it's just gonna accept this, right? We don't even have to cast this pointer, and we have UB here, right? You're less likely to accidentally pass the same pointer as both argument, as the types are different. Also, no, I just passed the same pointer, right? It just gets it wrong, right? Well, I guess the moral of this nonsensical story is don't try to write unsafe Rust with an LLM, right? I'm happy that... So back in the day, Rust 2015, right? It wasn't uncommon to use nightly as your daily driver for your compiler, right? Because there was a lot of features missing from Rust, right? And there was quite a lot of, oh, you should like do this because it's faster, and people use pointers, and there was a lot of unsafe Rust in the early days of Rust, yeah. And that's not just the interaction with other external libraries, right? It was like a lot of unsafe Rust being written around 2015 to do things. People did various hacks to increase performance and stuff like that, right? That is no longer that relevant. Writing safe Rust will generally get you the performance you need, okay? if you are going to be able to squeeze out more performance, you really got to know what you're doing when you go into unsafe. Not just about the aliasing rules and that, but you're going to understand why you're going to get that performance, right? It doesn't make sense to go, but I'm a C++ or C developer, so I like to work with pointers. Like, that's completely sidestepping the language and making your life harder, right? Brian Cantrell did a talk about this where he showed, well, I don't actually know if he showed the numbers, but he talked about this and said, I wrote this thing in C, I wrote this thing in Rust using Safe Rust, and Safe Rust was actually faster, right? Now, obviously, that depends on what you're doing, and it's ridiculous to compare languages like that. You shouldn't compare languages like that because like, you're comparing apples and oranges, right? There isn't really a one-to-one comparison that you would make. If you're writing Rust predominantly and you compare it to C, then you're going to try to write your C code like you write your Rust code, and that's going to be stupid. If you flip the tables there, you write your Rust code like you write your C code, and that's also insane, right? So they're not the same thing, right? That doesn't work, Papers, Please. I've tried that as a joke. I tried to get it to explain higher rank trait bounds, and it couldn't even get the acronym right. Sorry, the initialism right. It kept saying that HRTB was high precision timers or whatever, and I'm like, what? No, but you know, all right, yeah, it doesn't work. Running this locally is meaningless, right? It is rough, all right. So unsafe Rust is difficult to write, but this was back in 2015. You don't really need to write unsafe Rust, and the reason I can say that is because, one, if you do have to write unsafe Rust, you know about it, so you know that my comment doesn't apply to you. If you don't know, then you probably don't have to write unsafe Rust. Yeah. But yeah, now the LLMs, by all means, use them. It can be fun, but you gotta understand what they actually do, right? Yeah, you might as well. Yeah, it depends a lot on what language you're doing as well, right? If you are using a new language, I don't think LLMs today will do well with SIG. Maybe, but I don't think they do, right? Anyway, beautiful, fun, and here we go, right? Let's see if we can fix this though. This is a little bit confusing. So we would call two animutes here, and then downcast that. But for some reason that doesn't work here. Asmute should give us an option. So this gives us an option here. And I don't get why this is... Oh, it's because of the value. So this will work. This will get us this one. But it's the value that we're supposed to get. So this is not the right thing to do. This is now our mutable reference to an owned value. So that would be it. And then we have to say that this is a mutable reference to a dyn. I said mutable and then I didn't write it. Dyn any. But for some reason this is failing. But I will say this, I don't hold it against you if you are using LLMs for programming, right? Now, I have to confess that the term vibe coding is a little bit silly, but maybe I'm just old and cynical, right? Filthy old man. don't like the vibe codes. But and that's like you're not gonna get any gold stars for handcrafting your code if an LLM can do it for you, right? In the same way that you're not gonna get a gold star because you don't use syntax highlighting or whatever, right? Rob. But you gotta do what works for you, right? As long as the code you get is the code that you want and it's the code that you know that you want. Okay, that's the important thing. I will say that I'm actually, so this I would strongly disagree with, except that I don't, okay? And I'm gonna tell you why. As someone who's working on open source software, if I get an onslaught of PRs that's been generated from LLMs, it's gonna take no time to generate the PRs, and it's gonna take a lot of my, like, a lot of cognitive effort to review the code, right? And that's one of the things I really, really detest when it comes to this, because you're pitting multiple machines against a single human for quality control. And this is so bad. It's like having an art competition where there's 3 artists and 30 nerds with Stable Diffusion or whatever latest ChatGPT thing is using, right? And don't get me wrong, I actually have used LLMs to generate images. I used to play Darkest Dungeon on stream for a bit, and this is my backdrop, right? This was generated by an LLM, so in between games, and I think this image is really cool. I think the LLM did a really cool job. I said, generate something that is in this graphic style of the Darkest Dungeon, right? But make it bunny-centric because that's the stream, right? And I think this thing is bloody boss, right? That's a really cool picture, right? But I don't think that it would be even remotely ethical or moral of me to submit that picture as my work to an art competition. It tries to vibe code Web3 contracts. Well, luckily this is not my space though, so I don't mind what people do there. If the code works and passes the test, then who cares? Well, I care if the code is wrong and I have to sit there and review a lot of wrong code. I don't know if this was a response to what I said or not though, right? I'm tired of reading coworkers' code that does something like loop through all files in the directory, find a file they knew the name of. And the LLM wrote the test. Yeah, so, I mean, it takes no time to bang out code and tests, but if you're going to contribute to something that I'm working on, I want you to put in at least half the effort I'm putting in, right? Which means if I have to read through what looks like legit code, but it's a hallucination, that's gonna take a lot more work, right? It's a lot harder to spot some bad code when it looks good, right? So what does that mean? You might be doing something stupid, but your average programmer is not gonna assume that it was done out of stupidity. So the code looks right, but it does something wrong, right? And this is the problematic thing, right? Because in a project that is over 20,000 lines of code, it's really difficult to know everything it's touching, right? So you go, all right, but you write some code, please provide some tests, and then you have a test that does almost nothing, right? You get like 20 lines of test code, which is maybe 3-4 different tests. All right, looks like you tested this, okay, cool, right? But no, it completely misses the point or whatever, right? It just becomes tedious, right? Which is why until until an LLM can do better than I do, and you verified, I don't want that in the project, right? I don't care if you use an LLM to get the results you want. That is perfectly fine. That doesn't bother me, right? But I do want anyone who contributes to open source to not just use an LLM. If you use an LLM to produce the code, fine, but you got to review the code and make sure that it is sound, right? Okay, let's see if we can get by here, right? I would love for this to work. So what are we doing here, right? We're gonna have the value dot val. Oh wait, hang on. Okay, so we already gotten the value out here. So that's a mutable reference to the own value. So we are looking at the value dot. Yeah, why did I copy that? That's kind of dumbass. At least I know when I'm being stupid. Then we're going to do that, and that would be equivalent to this. And then we're going to downcast that value mutably. So this should be fine. Why is this not fine? The box thing here we might have to do that. No. Why does it claim that the type is changing though? Maybe we can't do this. Chronex, that's opt out, not opt in by default, so. Okay, so can we get this one to a dyne state first? And then can we cast the state into an any? It's not going to change though. What am I missing here? Well, that's still going to be problematic though, right? Imagine, Holy Diver, that you got rid of all the car mechanics. All right. That wouldn't work because you still need to know, even though cars are more complex, you still need someone who understands how the car works, right? You can't get rid of the people with the knowledge, all right? Or get rid of the engineers or whatever, because when there is inevitably a problem, you need someone that can understand that problem. It can't be like, and we are way too far away from that to be the thing, right? So when we're talking about replacing programmers, we have to change what programming even is to even get there, right? And we are not that close yet, right? You basically still need programmers to program. They might be inputting prompts, but they are still going to have to do the programming. Because programming is not just about writing syntax, it's about understanding the logic. Cast T to any. We don't have that. There is. Okay, hang on. You might be onto something, Scott. Let's see what we get here. So that's an owned value. Yeah, that's the option. And then what is this? That's a dyne state. You can't cast a dyne state to T though, Skylar. Yeah, we're probably gonna have to reintroduce these things, but I would love it if we didn't have to. I managed to get this working on this one. Here it works, but there are more steps in between here, and I'm missing some detail here. Okay. So that would just be value now that we would recast. Because that's a dyne state. Then this thing is nonsensical. What is wrong here? So this is what we do. We get the owned value. This is a dyne state, and a dyne state should be... Oh shit, is this because of the option thing? Which state is it that is even failing, right? I might be looking at this incorrectly. Yeah, we're getting rid of option. Why is that map there? There isn't even an opt map. Yeah, we don't have opt map anymore, so why is that even a thing? It's because it's trying to get the state. That's why. It's the index state that it's trying to grab. Yeah, it happens regardless. And we're not doing any messaging either. So that's not it. So a unique is wrapping what? An owned value. And an owned value stores a box dyne state. And we store the information about what that is. So that value, when it's written, can never change. What would your argument be, Perkins? I think CI or CD is going to be frustrating for pretty much anything you do, though, Lukey. Whether it's Go or not. I'd say if you want a reason not to like Go, and I'm not a Go dev, I would say error handling and visibility qualifiers based on capitalization and the beautiful date thing, right? But other than that, Go is probably quite good, right? All languages gonna have their quirks and stuff, though, right? CI/CD is hard with Rust. It depends on what you're doing with it, right? It doesn't have to be. If a slice is empty, is it nil? Really? Well, I can't say what CI/CD is compared to Go because I never set up Go with CI, continuous integration or continuous deployment. And I've done that for Go, so I can't really say anything about that. I would imagine that it just some kind of GitHub action for Go deployment, right? You can even do this without, you can just click buttons. Look at that. Is this worse than Rust? I don't think so, but I don't know. Again, I have no idea. This looks not far away from what you would do with Rust, does it? But again, it depends entirely on what you're doing, right? So I don't really have a horse in this race, so I can't say. All right, so we're going to get an owned value out. An owned value holds a dying state, and we're... Let's do this. Let's put a breakpoint where this thing is failing, right? What has happened with the Rust panic function? Is this no longer there? Let's say yes there. Let's have a look at the Rust codebase. Let's search for function Rust panic. Maybe that function has gone away, right? Can we search in a different branch maybe? Is there a, we can look in tags maybe. Now, will this thing search in this one? Yeah, I think this function has changed now. So it's supposed to be inside panicking. Let's have a look at what happened with that function. So at some point that one went away. Lib stirred source panic. Man, it's painful, right? Let's just turn off JavaScript because it's bloody painful to navigate this thing with JavaScript on. There we go. Now we can turn it back on again. No, it's there. Huh. What is it that has changed then? Wait, why do you have the wrong line number, Skylar? Oh, no, there's two of them. Never mind. It looks the same, doesn't it? So why can't we break on that anymore? Do we not have the Rust source anymore? Wow, we have some stuff we can get rid of, don't we? I don't think we need stage 0 or stage 1 anymore. We don't need nightly 2021 either. Right, we can do with these. Do we care about the WASM 32? No, I don't know. What is it the one we need for this? Is it install? Component. We have cargo clippy. We have Rust source. Okay. Let's do this. Let's remove Rust source. Can we not do that? Okay, I don't know. I don't know why this isn't working. Oh, is that a binary? That's not quite right. Well, how has that happened, right? All right, no answers. Okay, so we can do show directories then. Let's make sure that that code is actually there. Yep, there it is. No. Okay, so why is that not loaded? It is here. I am not. Oh, this is annoying. Ah, yes, that rust. Come on. I did. I haven't made it public yet, Loki. I will soon. Need to fix the code that runs this. Yeah, this is something else. Okay, what could this be then? I need to be able to debug. Otherwise, what's the point? Okay, so what do we get if we do this? We don't. It's from 2015, maybe that's why. Not only that, Lucky, but we can change it while it's running, right? We can change the messages. Let's say that it's not bold anymore, right? Or the italic thing has a bug in it. Well, it's not the italic thing, but yeah. So there's it has auto loading and everything. So yeah. Oh, the source for the program itself is really basic. But I will show this. I will happily go through this. I just gotta figure out why this thing isn't working. Just Skylar's just. Oh my god, that hurts more than you could possibly imagine. All right, so directory. Let's try this. Wait, no. I thought that would show us what directory it is. Can we add this maybe? Right, what if we reinstall Rust GDB then, right? Rust up, component, remove Rust GDB. Okay, what installs Rust GDB? Not that. I know, Skylar, I was being silly with you. Sorry. Okay, is it with cargo we get Rust GDB? Oh, this is driving me crazy. No, we just checked that. Let's see if there's a GDB in here. No, there isn't. I think it comes from cargo. What installs Rust GDB then, right? Oh. The Rust up tool, but I mean, we literally just checked that. Okay, let's remove everything that is Rust now. What if we... I don't think we have anything here that is relevant, right? What if we do Pacman Rust up? Yeah, so let's do... This is a bit sketchy. Okay, and there should be no Rust up. There is, okay. Nightly unstable. Come on. Okay, so reinstalling that didn't work. Okay, let's do this then. Let's go to... All right, we need to add Rust Analyzer as well. Install. All right, Rust components. I'm going to add Rust Analyzer. Probably need Rust FMT as well, right? I did mean that. I would love to do that, but it's a bit difficult when you're streaming. Okay, but now we might have to add Rust source, right? No, is that a tool chain? It's not Rust source. Is it stable source maybe? There's no tab completion there. Can we just get a list of the tool chain? Okay, so Rust tool chains. Let's see. Okay. No source is not listed. So it's not a, but it's not a component. It's the tool chains they want to see, right? Channel date and host. What are the sources? Other installation methods, profiles, components, tool chains. It's not a tool chain, it's a component then. There we go. So it's a component. Rust add, Rust component add Rust source, right? There it is. Okay. Fiddle my stick. Mm. Okay, so adding the source does not seem to help here. Doesn't seem to be anything based on this. The current tool chain. Okay, so rust up. Let's make sure that the default is... All right. Okay, let's do that then. Okay, ensure the source file present. You have correct debug symbols. All right, fine. But can we get some actual useful stuff here? You don't think it's a problem with Rust source? No, it's a problem with the GDB not having the Rust source available, right? Okay. Okay. No. There is supposed to be... All right, let's do Rust GDB. There's a Python script in here somewhere. this. Maybe. Okay, do we have a default? We could add this. And where are these located? This is not it, though. Okay, maybe that's what we need to try. Come on, man. I shouldn't be that. What is the issue here? If we can't break on that, it's going to be really difficult to step back from there, right? So you're clearly using Rust GDB, and then if you're using VS Code on Windows, why is this the accepted answer even? All right, never mind. That's not the issue, though. Would we have that? After running Rust source, what? Oh, I miss Razer. This is just gonna make me angry, I think. But this could be something to look at. See, this is why I was confused why Rust GDB was a binary. User bin Rust GDB. Okay, so right, let's remove everything Rust then and see what stays. Right, we're really going to town on this now. Well, I kind of need that one to run. Right, so let's do a... Well, I don't know why I did all that, but... All right, we're just going to wipe everything that is cargo. And Rust up. Yeah, there's no cargo. There's no Rust up. There's no Rust C. And there should be no Rust GDB. Okay. Holy. That might be the issue. That might be the issue. All right. Okay, I have to do this in another window. Okay. No. Oh, hang on. How are we in Rust up? Yeah. Come on. Do we get a GDB for this? Maybe. It is there. So that one didn't really do anything wrong. I don't think we need that one. All that. Okay. I'm losing my bloody marbles. Reinstall GDB. I don't think we need to do that, but I do wonder if Rust GDB adds a... Actually, we could try this. Actually, let's do this. Control G, please. What the shit, man? Okay, this thing died again. Man, that thing is doing my head in. 9:30. Okay. Okay, so pretty printers are loaded. If you do this without Rust GDB, if you just do GDB, target, debug, upcast, break, main rs28, run, sure, and then print data. Oh no, it does the same thing. Why does that work? Oh. What the shit? Python embedded in your Rust binary? I'm not sure what you mean. I don't have any Python embedded in this one. I have it in another one, but that's a different story. Okay, I'm running out of things to try here. We have this. Why is there a nightly there? I don't have nightly installed, but okay, whatever. Okay, this looks right. Whoa. What? Oh, this is just painful. All right. Bollocks. I'm not doing it then. We could probably manually add it then. So it's being added to the Python path. Is that what we have in there though, right? So this is a symlink pointing to user bin rust up. What? Oh, wait, hang on. What? Why does that point to rust up? That seems really weird. Welcome, Raiders. How you doing? But what's the arg to run GDB then? There's no rust up GDB, right? Still nothing. Sounds good, you, Serge. Hope you had a good stream. Okay, so Rust GDB is not happening, so I can't debug the... When did that happen? I mean, we got rid of pretty much everything. And I never installed the nightly toolchain either. Fair enough. Okay, so trying to get GDB to include... Okay, let's manually add it then, right? That's at least we can do that. So GDB add Rust source to directories, right? So we just do that. Oh yeah, we've been there. Let's see if we can... One of these actually has the information we need. Show directories. Okay, so how do we add a directory? And where does this get added? I think that gets added by the... So if we do this, okay, Rust GDB, show directories. I think this is added by that Python script in Rust up, right? If we say that this is now a sandwich instead, like you do. Yeah. It's not there, is it? I think that's not showing the right thing. Well, I guess we don't even have to do that. That's there. And then we get the lib it's there. No, it's missing something. That's clearly a longer path. That's not here. Uh, okay, so that adds directory. Can you add another directory? Set substitute path? I don't get this one. Why would that be a /? Is that wrong? Is that a typo? Should it look like that? Where's the source code for this? No? What does set substitute path do in GDB? So this is what you get. Hello, Cocadora. How you doing? Okay, let me see how mine differs from yours then. Okay, so if we run this, can we run this from GDB? But it's not reading the symbols from there, right? Ah, damn it. So is it not including the Rust C? Okay, if you guys have the same source path and you have the same directory, then what the hell could it be then? Then I don't know why this wouldn't be working. What version of GDB do you have? 16.3. Yeah, now this isn't new. I'm guessing you have the same version. Yeah. Man. Okay, let's do this. Make sure I don't have any GDB anywhere else. No. So even removing the custom config didn't do anything. But it tried to do this. Okay, but how did you end up there then? How did you end up not seeing that? Because that should be loaded by default. I'm assuming yours isn't broken in the same way as mine. All right. I didn't even get that though, but I'm guessing you did GDB with this. Well, I'd imagine that if you were to load that, okay, let's do this. Let's run GDB and then let's do GDB add source directory. Let's see if we can add this during runtime. Okay, so we should just call directory, right? So let's do rustc sysroot, right? That will be lib rustlib source rust library. Right, this is what we want to add. So if I do directory you. Okay, let's add that. Really? Oh shit. Oh, it's not. Wait a second. Where's the panicking? Okay, there's panicking. Why is... Oh, that's looking for a file, you idiot. Not a directory now. No, that's true. Adding the source would make the debug symbol appear. So maybe we need like Rust debug symbols. Nah, this is gonna be specifically for what? No, this can't be the solution. Rust source debug symbols missing then. Oh, it's incredibly wrong. To what though? Where are the debug symbols? Let's do this then. Rust standard library debug symbols, right? Oh, we can get some pictures of them. That's good. I am doing this with a basic library, Dotty. Okay. Okay. Is this a thing? No, that can't be a thing. What has changed? We'll use another computer now. But that's not something that we can control, right? Put a panic. We have a panic in there. This is literally panicking. All right. Hmm. Yeah, it did. Okay, let's try another computer. No. It doesn't work there either. Huh. Hello, raga, how you doing? I'm trying to figure out why Rust GDB isn't working. This is a completely different computer and it's got the same issue. Wow. Let's uninstall everything on this computer, right? We even had Rust source there. Okay, so now we don't have GDB at all. Let's do not a reboot. Let's do a sys update first. And now it should, oh wow, that's a lot. That'll take a while. Does NM, I don't know what NM is. List symbols from object files, okay. Okay, so I can't get the debug to work. Can we step into it though, right? Let's do this. Well, that's clearly an issue, but also we are obviously seeing Rust code here. So this is somewhat working, but this is clearly not right. Okay, we might need to install that. So let's do Rust up. Toolchain install nightly. Oh yeah, we don't have the language server installed, but that's okay. We don't care about that. It's getting there. LSP config. Okay, so that's the language server. Let's fix the language server then. Right, Rust up, toolchain, no component, add Rust analyzer. There's no issues stepping into the code. This is literally the panic function. Well, no, it's panic format, but we are in panicking here, right? But shouldn't the last line of panicking be more lines of code? Hang on. No, that can't be it, can it? Holy crap. Yeah, but why? Why are we in core and not in stud? Okay, but we should end up in panic though. Okay, now we're there. All right, so I'm going to set a breakpoint there and there. Okay, so we only get that. All right, let's run this again then. Fuck. Yeah, we don't care about that. So Rust up is now a thing now. Not enough free disk space. Oh, should probably see to that. All right, that will be a different story then. You cannot with 187 pack? Really? Okay, you might be on to something. Wait, Skylar, what version of Rust are you on? I should have asked you that before we even did anything. You're not 185. Come on. Okay. Not you, Skylar. You did great. Okay. So could this be an issue with 186 and onwards? let's search for that is a question. This is a different issue, but still. That's all right, Pack. Oh. Okay, let's see if we can find something here. No. Oh, man. Arm break? Okay. Damn. Oh, damn. So we have to use R break instead? Oh, man. So it wasn't me this time. Damn, Rust. You have thrown me a curveball there. Ah, man, you don't assume that Rust is going to be the issue here, but yeah. Okay, so it turns out I'm not the only one who does this, and that was a complete waste of time, but oh man, I don't even remember why I was doing this, but here we are. What a bloody mess that is. Oh, early adopters, yeah. What was I looking at? Demo. It's not really relevant that we break there, right? What is relevant is being here. Yeah, so that is the index state. Okay, cool. Well, it was educational at least, right? It was painful, but that's how you learn, right? I didn't even know about R break. All right. So this is the index. Why are we not getting that? Type ID, type name. There's so many things called type ID in my code, so I don't know if you're referring to that or something else. We can't call functions that are defined on traits, though. Yeah, but that's just a numerical value. That's not going to help you. You could look up the value before, I guess. But what I think has happened is something else, though. See, this is a boxed down state. It's a value boxed down state. But you can't on a trait, right? Okay, so is adding the value the issue maybe? When do we insert the state? I wonder if that's the problem. We have one level of interaction that shouldn't be there. Oh man, that bloody fan. That bloody fan is... I'm not a fan. Oh. This, I think, is a bit of a culprit. That's clearly test code. So this is casting S, which is a box down state, to T state. Yeah, that's not great, is it? What is this thing before we do that? It's a dying state. Okay, let's see if to mute cast is part of this. What is self? Is a box dying state. That's why. To mute cast doesn't do anything. It just changes the type. And it shouldn't. It's a bit sketchy, which is why the doc is hidden here. Okay, so it is a box that we get. So I think the issue here is that we're casting a box to something. Yeah, that one doesn't have anything. No. It's a box dying state still. So this is a wait, get unique. What do you do? Okay, so this returns T, and that's going to be a box dying any state. So this is a box dying any state, regardless. Come on, there we go. There it is. So I think this value here so we're first getting through here and then we get here. And what is this value if not a box dying any, right? Ah, see, that's a problem. This worked with all the boxes that we had because they would just automatically dereference. But now they don't. Wow, thank you for the resub. Thank you, Godstreams. That bunny cheered me up. Okay, so that is sort of an issue, right? When we're doing that cast, let's see if we can get rid of that somehow. If we get rid of this, that should break a bunch of things. So we know what T state is. Actually, we could make this thing. This one doesn't have the value. No, it doesn't. Oh, that's what it is. So that's a problem. So what we actually get here with to mute, which I thought was going to be in here somewhere. So we should call to mute first to get the value. The only difference here is that we're changing the type. Because everything is stored as a box-dine state. That's why. What a beautiful mess. So we lose the type information that we need. So that's not great. So we need to call to mute and then downcast. So down to mute cast should not work. It should not be there. It should be to mute. And then we should cast this. That's a box dine any state. And then can we do on a unique, maybe we can cast there. Ah, okay. Yeah, this wasn't that simple then. So what we have, this type here is what has to change. And we can't really cast that. Yeah, that's obviously what we're gonna have to do, isn't it? Because we can't go from this box to a reference to a cast, right? Or can we? That's an option of an owned value. What the hell is an owned value anyway? Oh yeah, owned value.val is what we have to cast. So we could add a function here to cast mute. Like this. Yeah, that's what we're doing. Well, first we have to get this into an NA. We don't have any functions for that. Can we cast this to a unique? Maybe we could do. No, we can't do that. I am so hungry, so tired now. Oh. That's the owned value. Oh no, hang on. We could just dereference that thing. Ah, okay, hang on. Undo everything. Let's get rid of you. Yeah, we'll get to you shortly. Stop it. That is own value. That is the box. Is it not? Why can't I get to the... All right. There we go, right? That's what we need. We have to double deref this now. No. Then this is fine. Why was that not fine? We did the dereference. So what is this stored as? This is a value of a box dying state. So the value that we get out of there when we do to mute cast is just changing this. Oh wait, did I change the wrong thing maybe? I might have just fixed the wrong thing. Yeah, I did fix the wrong thing. No, damn it. Yeah, I am. But I kind of need to make some progress with this. But yeah, I am crazy hungry and very low blood sugar. Now is a good time to be an asshole troll if you really wanted to get under my skin. No, that didn't fix it. I would have thought by dereferencing this val, we get out of the box. It's a dying state. So we can do the monitor check here on the own value. And then here, we are getting out of the box here. Yeah. I don't care what you see, Skylar. Okay. Go and look in the corner. I'm gonna do this. So we have gone from box dine state, which is the original type of this. So really, the to mute cast should only be implemented in one place. That should be implemented for value box dine state. Because that is what we store in states, right? Why are these things? Oh, I took the wrong function, you plum. Okay, hello. Like that. See, that's the only thing that should be castable. And whatever this is, it has to implement state as well. So when we write something into the state store, that is just a homogeneous collection of trait object, of box-dine state. So when something goes into the state store, we can start from there. So this one stores that. So when we insert something, we are effectively... we're putting in a value box-dine state. There should not be a lot of places where this is actually used. Well, that's a test. Ooh, okay. Hang on to your sockets. Get component. Okay, it's just a composite state, which makes sense. Maybe they shouldn't be values then. They have to be values. Okay. So we're casting these at some point, right? when we call get component, is there a set component somewhere? State is that. And that should become a box new edit state. So what we store there is a box dine edit state. So at this point, we should be able to cast this any state into its underlying type, or upcast this to any and then cast that, right? So when we get it, we get the any state. So that's fine. Thank you so much, Scott. Thank you, buddy. Hope you have a good day. So we insert these and we get these. That's a reference to a value of a box dine state. Okay. So what's in here should be castable to any and then to the state type. So we need to get it out of the value. So we've gone into the box and we're going to get out of the box. Oh, no, then this should be fine. This should be okay. And then we just make a value out of this. And the type information is stored on the widget. Okay, so where is this breaking? Because the type has changed. Is there anything that is happening in between? I can't break there. Let's do... We get the own value and we know what this is supposed to become. Oh, okay, wait. That's not great. So that's assuming that this value is a different value, right? Oh, no. Well, no, that's right. So and we're doing this with to mute. Why? Where's the unique? Am I blind? No, there it is. So we've already converted this, but that doesn't mean that the conversion is right. So the value that we have here all right, I need to do this from here. Oh, here it is, right? Oh, wait, we didn't even get here. So that is the state. Which is now an index state. So dereffing this mutably. See, this owned value, that is a Box-Dine state. Damn. And we are dereferencing this thing. That's a Box-Dine state. That should work. Okay, so we're going to try a few things here then, right? That's an option. Who's making the food today? I'm pretty hungry. Yeah, we couldn't do that downcast. Oh shit, could we downcast this thing directly? No, we can't take ownership of that, can we? No. We can't move that out. So this should be analogous to calling deref mute, right? What is the type then? Try Box-Dine state as the type. Here. Hello, Rudy. Yep, that's it. But that's just casting it back, right? Okay, I don't know if we tried this in the upcast example. So let's do this. That's just putting it back to what it was, right? I think we need a different approach to this. Let's get a box of a state here instead. still works. Well, if it was a box, then could it be a box? No, because this works. So it couldn't be a box here. Why can't it be a box or a box? Where's the second box? All right. This holds a boxed value. Oh, I see. But then we should be able to, so this downcast just puts it back. So we need to, okay, hang on. So to get this to be a box of a box, because we're casting it back to a box, right? We have a state. We're getting out of the first box. Right. So we would have to do this. And we have to dereference you. Like so. Maybe you're onto something. Nope, go to your room. Double deref, but how you double deref? It's not two boxes, right? There we go. Yay, you can come back from your room. You're right. Good work. Good work. So that's the issue. It's double boxed. Go out to another room, Falinder, and then go back to your room. It's all good, Scott. Why is it double boxed? That is a question. Why is it being double boxed? Shut up. Go to your room. Why is it double boxed though? Oh, I'm hating this project again. That means that this thing is exhibiting the same issue. Okay. How do we get around this? We need to see where it's actually doing the downcasting, right? Or the insert. So from here somewhere. Why are we not test all of a sudden? Where the hell have we been? I can't be bothered following all that. Let's go to runtime. All right, let's go back to having this breaking now. Yes, Skylar, that is the issue. Damn, you're on fire today. And I'll show you why that's an issue. That's because, look at the new function. We're boxing the value. So why don't we do something that... If we take... Oh, it's well sketchy, but this is what makes it sketchy. There's a reason the doc's hidden. Like, this should not be used, right? But we can't box this value. Instead, we have to take that. That should work. So I would think that this would just make a... Does this not implement that? That's gonna be unwieldy. No, you can't do that. Can we then say... No, state is implemented for box-down state. Fudge. Can we do this and calm this one down for a second? So this would be correct. Come on. There we go. That would be fine. That would be fine. That one would be fine. So with this... Okay, so it's only where we insert this into states. So I think this could work. This is the only place, right? It's not really that great to do it this way. Let's be clear on that. But this is a box-down state. So from box. No, no, no. This one only takes the box. And that one takes the cake. Okay, so maybe... Yeah, all right. So value module to whatever. Now I don't think we need this anymore. Right, we got there. We got there in the end. Damn, what a journey. All right. I hate programming sometimes. And today is one of those days when I'm just like, I'm so fed up with it. I don't know if that's true, Scott. It barely in that case. They might even be tied. Welcome, Filicus. That's the wrong one. All right. That should have probably been done anyway, right? Welcome to hell. Come on, man. You can't be mod anymore if you say things like that. You're scaring the people away. All right. No, it's more like I just get frustrated with programming in general. I'm tired and I have no confidence right now. This looks like an alien something rather, but it looks a little bit too happy to be alien. Alien, but also with Harry Potter. Is that like Flight of the Navigator? What is that? Is it like Harry Potter and some kind of goblin next to him? Then if I know what this is. All right. Yeah. All right then. That was our game. Why is that a game? So you can moonwalk and throw a hat at people. That is the game. Oh yeah, and graphically it was pretty good for its time as well. Is it possible to be a Twitch streamer and sort of grow a smoldering hatred for people? I'm asking for a friend. Okay, but the issue is fixed though. What about the other way around? Oh no, I think that one is already there though, right? No, I just hate programming today. It is good, but I'm frustrated that I didn't see that myself. I am incredibly frustrated with myself for not spotting the double box. But DREF is still broken, I think. Or not? No, that was fine. But there is only one place where this is happening, and that is when you insert into states. Which means that the from box can be limited to the crate. Yeah. I think that the dref is right. So we're going to get the value. Instead of using as mute, we use as ref. And then here, we can expect this. Instead of this unwrap here. No, I've failed to solve the problems I set out to solve today. I couldn't figure out that stupid ass bug in GDB. And I couldn't spot the double boxing in my own code. Don't worry about it. I'm going to go throw a temper tantrum somewhere else. I'm not going to do it on stream. Okay, I think we're good. Now, this was the introduction of all this was with the introduction of the maybe type. So things can be nullable. So can we when was this code written? It's not. Here we go, right? Hours ago. And now I can invalid type. You Rust. Oh, beauty. Okay. It shouldn't be difficult when you've been doing this for a few years, Scott. It's a rookie mistake. Why is this giving me invalid type? Come on, man. Hmm. Yeah. Although I think the blown fuse is in my brain. Invalid state. Why? Can't see what that is. We're not out of the woods yet, apparently. Why is it in an invalid state? And why is that a double? U is for what? Unique. Oh shit. Wow, okay. That's not good. Why are we getting a unique state here? No, that's not it. We're not calling to mute either. Shit. Where? How did I change that? Where did ownership go here now? Are all of these broken? Type should never change in the list. Wait, is the insert and is the remove function failing not from the map but the list? It's the bloody list, damn you. Yeah, okay. So I think there is one more place where maybe insert is failing. I need to go make some food as well. I'm being a bit stupid, but also I can't stop now. Oh no. T can't be a box, right? So that should just be T. Are you a... No, you're a value T. Okay, we'll panic here for now. We'll come back to you. So that's just gonna be... Fine, be like that. Why is it in an invalid state? Have I taken out something important? Oh shit, we didn't get here. Thank you for the follow, Richard. Hope you're having a great day. We are returning the value though. What the help? Oh wait, this looks like it's doing something and then some. Okay, let's debug this function. No, that's incorrect. This is an owned value. And this is now changed. This has now changed, and you will change too. This is a an invalid type. Okay, so how do we do this in the... I mean, we literally changed this, right? Wow, what did I do? Here we go, right? So value as mute to get the value. That is our mutable reference to that. There's no deref mute on there. I don't agree with that. There is now. So we're going to go from that to any. And then it goes invalid type. Why? It says the type should never change, but what does downcast mute do for us here? That's what the any does. That's not a boxed value though. It is a boxed value. It's a boxed down state. So what that is a boxed down state here. And what are you supposed to downcast this to? A list T, is that right? Invalid type, come on. Self is a list T here. It's a, oh no, it's a mutable reference to a value list T, okay. That is right. This is our list. Oh, when we return a value, but we return in the inner. And that fails. It's this thing that conks out. Everything is fine up until this guy. We have to return the value, but what is inner? Get unique is an owned value. Uh, everything is fine until we go to return the value, but inner hasn't changed, right? So this thing is an owned value with a box 9, whatever state, and return owned. Again, not the issue. Wow, okay, more debugging required. Okay, that returns 0. Why would you return 0? Oh, because we returned the index, you plum. Okay. Come on. Owned entry. Why is this failing? Oh, I hate this thing so much right now. Hello, peoples. How you doing? This is... thank God we have... No, fuck that guy. He didn't do anything of this. Thank goodness we have tests. Sorry if you feel theologically accosted there. This... the frustration is real. Why is returning this thing broken? All right, let's take it here and try it in here instead. So we do something like... Is that public, by the way? No, it's not. So we can... Well, we can do an insert from here. So let's just say self dot... Some kind of list. Left. Push. This should fail. And it doesn't fail. Right. What is it that is causing this to fail? Push back. And it's not failing. That did fail. I think. No, it didn't. Why is that not failing then? How is this different? Oh shit. No, new value wants a box. That's right. No, that's not the issue. Invalid type. In value mod 248. Why are you alive? Why is this here? I gotta make sure this is the right test. Fudge! It's not even the right test. I'm looking at the wrong test. Oh, it's not my day, I tell you what. It's not my day. Okay, now this list insert fails. Let's go to map. Insert. We're gonna panic here. Okay, so where does the invalid type come in here? Wait, let's bail. This is what's causing it to fail. Still fails with an invalid type. Is it the get function? Yes. Okay, you are the culprit. Because that's not a value t. Oh, that's just how it goes though, Scott, right? No, that's not an invalid type. What the hell? Hey, hang on. Will this work? If this will work, then... Okay, right. I've made a mistake. It's fine. It's all right. Come on back. Oh, the cracking noises. Oh, they are delightful. Okay. Right. This is it. So this will work. It won't work when we use toRef. Or I think this is the issue. But why? Okay. Yes, shared would have the same pain as unique, right? So obviously I have, if I fix one, I have to fix the other, you plum. Ah. Shared state. Try as ref. And here we go. How is that different though? What are you? You're an own value. Why is this thing? That's a box. Oh, right. Right, was that it? So we can get this going now. Not quite. We have to call to ref here. Yeah, we do. Okay, so this will work now. Whoops. Okay, beauty. So the issue was the same, right? We just had to change this to work in the same way, right? So we have to dereference the RC. I think that will not fix it, right? No, it does fix it. Okay, so that one's fine. We have to call as ref to get the... Yeah, so this would work if we would do this. Yeah. So that's what was missing. We just have to dereference that bastard. Okay, well, there's gonna be more issues. Well, it's a good thing that it does though, Skylar, because otherwise we'd never figure this one out, right? The copy value is probably something that needs, if it's not tested, it's testing too, right? But let's go to the map now. Find the panic here. Oh. All tests are passing. Okay, well, we managed to get upcasting going. We got rid of a whole trait. And now we can try this. So in our template, let's just put a v stack and say for L in state.left text L. Get rid of you. Yay, it's working. Oh my god, it's working. Wow. Okay. Can we get the new type in here now? The nullable. The nullable, not the null-bale. We can call it a null-bale if you want. It's like a null-bale of hay. Okay. Yeah, that double boxing thing, that really irks me that I didn't see that. I am finding it really hard to let go of being angry with myself for not seeing that. Okay, this compiles. Let's set it to some. Oh, because it's a value in a freaking value, then calling set is not the right thing to do here. Yeah, right. I was in the midst of writing these bloody tests now, weren't I? It doesn't quite work like that, Scott. Shit. It doesn't matter who found it. What bothers me is that I didn't see it. That's like it has nothing to do with anyone else, right? That's not in my head. It's that I didn't spot it. That's what bothers me. That the double box has been in there. How can we do this then? Can we just get the value instead here? So we do a get ref. The what? The no get ref. From maybe T? No, it's called get. Ugh. Yeah, calm down, Rust. Yeah, this doesn't work because it's a value. We can't return a reference here. Man, this is some bullshit. I mean, honestly. Alright. No, because the value can't become a reference, right? If we do that, Skylar, then we're just back to options, right? Then the maybe type doesn't hold any value. How can this even work for a value of a string? Okay, this option thing is gonna go away. Oh, it's implemented state for string. Oh. I guess we could at best implement as dref, sorry, impl dref t, but or return something that impls dref t, right? Maybe this is not how we do it. Maybe this is not the way this goes. So to get a string, we don't do these either. So the way this should be workable would be rather like that. And that should give us the value. But then what's the point of the isn't one? Where is this being used anyway? I think this is not being used by the end user. I think this is used elsewhere. Maybe somewhere like the resolver attributes. I think this is where that happens. No, that's an. Do we even have these? Are these state values completely nonsensical? Maybe they are. Okay, here they aren't. For integers, it makes sense, but that does imply that we probably have as stir as well. Yeah, of course we do. Of course we bloody well do. Come on. Wow, what a nonsense. It's going terribly, Felix. How you doing? Yeah, that one makes sense. So that's a shared state that we call that on. Which can dereference to a state. It's because the maybe holds an inner value. So we need to operate on the inner value. And it sums it up though, right? Not the best, but okay. Nah. It's all tickety-boo. It's great. Gotta get out of this funk, Felix. We gotta get out of this funk. What are we doing with our lives, huh? What is this? What is this bullshit we're giving into Felix? We gotta sort this out. So the resolver as stir. A different story, isn't it? So shared state, right? Could we get a different shared state then, right? This is why we can't call to stir on a dyne value, right? That's why we have to use to stir here. So it's not really... It's not that bad then, is it? No, we're getting to the end here, Skylar, right? We're getting to the end. This is the outstanding bug. Looking at the other issues we have, I don't think they are that difficult. Let's see. Show me open bugs, please. There are some API improvements to attributes. The better error handling for reuse components when you can't. Floating widgets get parent size. That one looks a bit more sketchy. Don't cycle every frame. That one is a performance optimization. Widget filter and the thing that I'm working on now are like the biggest bugs that are outstanding. So I think it's looking pretty good. And we're getting more tests in the process, which is even better. But this will give us a shared state, no? An option of a shared state. And it's because we own the shared state, we can't return a reference to that. That's why. Please do, Skylar, but it is not a simple thing to look into. So be aware. And I don't know what we're going to do with the component filter. I feel like maybe that one is just meh. But after this we're redoing the event system, which should be fairly straightforward. So I'm looking forward to that part, right? I'm tired of fixing bugs, right? Like these constant stupid edge cases. I don't love it, right? And I don't know how we're gonna deal with these like wrapped values. So really what actually happens here, this is actually simple. None of these should work. This is the only thing that this thing can do. And I wonder if this thing should return nullable. Because we have an underlying get here and get mute. These are the things that we should be using from the maybe. Or further your pain. It's all good. It's all good. should we have a null, a maybe type then that can wrap another type? So if you have a maybe, so this gets a little bit sketchy now. We add another type here to nullable. Yep, we have Python code here. So what do we do if it's nullable? Okay, so the pending value. Okay, that means that you have to be a nullable. And it's always going to be a dyn val. And where does the value come in? Like that. But it isn't. Oh. Or is it? Nullable can only be dynamic values, right? You can't have a nullable static value. That doesn't work. But a nullable dyn value could work. But how do we deal with the type? If it's nullable, then we need to get the underlying type. And nullables are unfortunately recursive, right? Okay, I think we'll try this. We'll try this thing, right? So if the value is a... So what do we do if it is a nullable value? Maps and lists. So that will be maps, lists, and nullables. That's our pending value. We're going to have to check all of these though, right? No, maps and lists are recursive, but there's a reason why doing something like resolving a Boolean value is that much information, whereas resolve index is a freaking book, right? So that's more why. But I think this might work. It's a little bit awkward to have nullable and that. So maybe this should not be nullable. Maybe this should be maybe. Okay, so resolving an integer. Now here's the question. Is this resolving the value once and for all, or yeah, so a nullable can't be static, as in it can't be defined in the template. Or rather, even if you did, if you had a nullable value here, nully the null, right? This can never change. So there would be no point in making this thing behave dynamically, right? That's what I meant. I'm in the wrong place again, aren't I? You are way too young to be doing drugs, Skylar. Stop it. Sort your life out already. You say you're not doing drugs, but saying looking at things and moving your head, that just screams, you know, some kind of psychotropic or whatever, right? Keep it that way, yeah. Okay, so resolving the value could change this to be an actual value or no. So should resolving the value deal with this or not? So this could return null. Do we have null here? No, but maybe we have there, right? Nullable. So a value kind can never be part of an evaluation chain. Only the return value should only ever be the final type that is held by a value at the end of an evaluation. Okay. I mean, you are not being very convincing now, Skylar, okay? I think we're all thinking that you've been on the wacky backy, all right? So resolving a value takes an expression. So we have 4 arrows left. So we have to do the same thing for nullable here, or for maybe here. So we can get the type from this, but we don't know, because again, there could be freaking nested types. Gotta remember that a maybe can hold a maybe, right? That is the problem. So we have to resolve them kind of how we resolve indices, right? That's a lot of year, Caleb. Oh, god damn. That makes me wonder what I've been doing with my life. Fudge. Think of something less depressing, quickly. Uh, damn it. Okay, we are reasonably close. Come on, brain. If we've solved this, then we can pick off that null malarkey. What is 0? 0 is a collection. And that's a value. It's a value kind. This one we can solve recursively by walking the values until we have an any list. So that one we can solve. What else do we have? Yeah, that one's fine too. That one is definitely fine. Is that it? Okay, let's solve the low-hanging fruits here. No, we can't do this, can we? How should we deal with a maybe value here? Maybe we literally need a resolve maybe where we have the index, right? I think that's probably what we need. So where do we resolve an index, for instance? Right, this one is kind of Grimbo. Ugh. But we need something similar for a maybe. And what's the input we get here? We don't have an index. We just have a value expression. And then in the event of that one's unreachable. Okay, so we only care if the value expression is a maybe. I like how there's a message to blame you, the end user, in here. But this is up to do, right? You probably did something silly, okay? Like chopping chicken. I have a meat cleaver. Mine's from Andorra. It's a great, very cheap meat cleaver. Cutting carrots. They're too annoying to clean for that, right? I mean, you can sort of lean it and just chop fast with it, but yeah, too much. Then we kind of need so what we do up here is state as any map. So we should do as maybe. Where's the unclosed delimiter, you bastard? It's in the wrong project. Okay, so state-wise, we're adding this. We're kind of following the... Shit on it. Any maybe? Hey. Not enough freefall. Not enough. Is there a map? Yeah, there's a map on maybe T. Ah, but we have some T needs to be state there. That is highly unlikely. What is it that we're getting out of there? Lookup gives us an option of a pending value. That should map ref. Where? Where did I leave that broken? Here. Okay, so resolving a value from... So where is this being used, right? Oh, what am I missing now? So I don't think this one is going to be a concern. So resolve value. Since the value can be null, I don't think here is where we do that, is what I'm trying to say. So value kind should be a final value, right? So if it's an index, we're resolving an index, right? If it's a maybe, then we resolve maybe. Is that not? No, it's a value expression. Why is it a value expression? Dine list. No. Oh. Okay, that would imply that a value expression of a maybe is not... Oh, no. Can a value expression be re-evaluated? This is what really ties a knot on my brain. Why can this index be anything other than a pending value here? That I don't know. It can't be. So these two are pending values. Well, we need to know the type, but we do that here. Okay, resolve int takes a value expression. Okay, yeah, I kind of get it. Because this maybe might be another maybe, right? There might be nested maybes, but can that really be? It can be any one of these dynamic versions here. Yeah, so then suddenly this could never be an index. So maybe not. Maybe that is okay. There isn't even the option to be... No, so that's fine. Because it is a type. That's why. Okay, so they are slightly different. Yep, got it. So that is not, that is a value, pending value, right? Well, welcome Raiders. How you doing? So this is the inner value. So we're going to match on, we want to type info here. How's your stream? All right. Enjoy your stream. Enjoy your run. Sorry, I'm very focused. So this thing has to return a value expression, right? Why are you not returning a value expression? No, that's why you don't return a value expression. Oh, my brain is gonna explode from this bullshit. We don't have, well, we have a resolve pending. Yeah, we have a resolve pending. So why is this even a thing? Right? Right? Ugh. See, to do this recursively, it needs to be a value expression, right? It needs to be an expression. Why is this? Is there a resolve pending? There is a resolve pending. But then there becomes a value expression maybe. I don't know if we want the value expression to be a maybe. Maybe instead we just resolve these. Oh, but then this doesn't work. Why is there no as maybe in pending value? No, you have to become a state first. I think we have an or null. Um, okay, that's something. I don't know how we're gonna do this though. We don't have a value expression for this. So this should be the same situation. That we can't do anything with a maybe here. See here, we're already doing the reload. So reload will resolve the value. The value will be a value kind, and a value kind should probably not be a maybe then. Yeah, I don't think we want a value kind that is a maybe. We'll get rid of that one then. Oh, Flip knows what we're gonna do here. Okay, but we're almost there. Yeah, Skylar, there is byte tag alone shouldn't be broken, but when you combine it, I think it's broken. How does this work? When do we call dyn string? We call it internal strings. And we call it recursively on a list. And when do we call internal strings? When we want to get something happening on strings. But this is on a value kind. Yeah. We shouldn't have a value kind that is a maybe, and we don't. I'm in the wrong bloody project. Okay, let's go back to states and finish the implementation, right? Yeah. So we can go call get on this thing. So the pending value is the inner one, right? So this isn't used anywhere. Okay, somewhere when we do our resolve value, something can be. Wait, where do you even come from? Right. What is calling this? A lot. Anything outside of here? Yes. Here we go. When we make a new value, we resolve the value kind based on the expression. And how do we get a value expression? Where do you come from? We get an actual expression that we then resolve to a value expression. Okay, that's obviously a problematic situation here. Some kind of dine whatever, right? Yeah. But this is just resolving just about everything, right? Where's the map? Where's the dine stuff? Where is the dynamic stuff in here? This doesn't make any sense. Ah, ident. An index. Here we go. This lookup returns a value expression. And this value expression could be this is what could be a maybe value then. So scope lookup is what's going to cause that, right? Ooh, that's a bit confusing, I have to say. Don't need that, do we? Oh yeah, it has to become a value expression. How does this work? Why can we only look up entries? So if it's a state, then we get a state back. If it's an attribute, we get attributes back. This code not too long. But remembering where the value is in the life cycle, that is the question. Because we have different value representations, right? I'm confused by this. Do we have an ident? We do. Oh, but it's always going to be an index. Okay. Okay. There will always be an index here. And what happens when this becomes a nullable? Right? So where does this panic now? It's the wrong project. Thank you for the raid, maybe. All right, so we don't do option list anymore. This would be a nullable or a maybe list. Right, whoops, near him now. And then this would be a maybe none. There we go. It's going all right. How is your stream? I don't think the set function here is what we really care about right now. We care about the error that's going to occur here. Why is it not broken? Why are you not broken? Why is it not panicking? I'm introducing optional values to the template. And I'm going crazy doing so. So we have a template. I mean, this application you were seeing here is built with this. And I want to be able to have maybe values or nullable values in there. Or default. Oh man, I have no idea why this thing is okay. Okay, so we're gonna do something awkward here, right? This is gonna be the maybe. And what's the interface for a maybe? I don't remember, so we're gonna have to look that up. Set, okay. Okay. All right, that's not working. There you go, right? That sounds pretty good. I wouldn't mind some kind of delicious cake. Well, I would, but I like the idea of cake. Okay, so now we have to go to the value resolver of this. And this is where my brain will collapse. Okay. So let's get out of the state. Let's get out of the store. Let's get into the resolver. So the immediate resolver is what we're going to start with. So we're about to resolve an expression here. Let's see what the expression looks like. Right? This should just be the index lookup with an ident of state and an ident of nullable. Actually, this is an either, so I should have simplified this, right? Yeah, so it's a text segment followed by an either. Man, I didn't even know we had text segments anymore, right? I don't remember any of this stuff. So we're going to simplify this by just go straight for nullable here. So this is an index where the key is the nullable. So let's go to the index resolution. So we now resolve the source, which is an ident. That source is going to be the state, right? It's a composite value, blah, blah. It's the state. Okay. We are... Wait, where did you go? All right, we have to do that again. Let's resolve this thing. And what is this? This is a string slice nullable, which makes no sense. That became a static string. Actually, that does make sense. It's the lookup, so it makes perfect sense. So we end up with an index of... Okay, so we don't have to do anything here other than look at what happens when we resolve an index lookup then, right? So this is the intermediate resolver, which will resolve value expressions. No pending values will be resolved here, and that makes sense, right? Cleaver knife. Could be nice, could be nice. Okay, so we have resolved this thing, which gives us a value expression. So let's go from here. We'll end up in two of these. And then when we leave the value expression, that's what we have with a value now. So it's what the value does. Yeah, okay, thank you. Here. Here, we resolve the value. So this should be the final, all right, it even says so. This is the final value for a node attribute or a value. This should be evaluated fully for the value kind, meaning we don't have anything that's left to evaluate after this, right? Sometimes free for when isn't it, right? Okay, so this is an index expression. So what do we get here? It's an integer. Holy, that's not right. Okay, so we have to run through this one again. I don't need that one. Resolve the index. All right, so the type in for here is composite. That means it's the state. So that's the value of the thing that we have, the map. And then we have the key. Oh, excuse me. And that is nullable. So we're supposed to look up. So we have a value now. It's an option of a pending value, but this value should be sum. And then we go to resolve a pending value. And this is, well, fuck you. Whoops, sorry. Might be, I'm sorry. All right, so the value new calls the resolve here. And we went to resolve index. Okay. So let's go up from here. Right? That's fine. And TI should now be, it's an integer. Why are you an integer? You're not. You're a maybe. You're a blooming maybe. You're not an integer. Okay, let's go up from here. That is a pending value. Maybe I've left a little bug in there when it comes to the nullable type. Yes, I have. Oh my garb. This is wrong. Isn't it type info? No. It's type. Okay, we can clear this one up. Put $1 in the swear jar. I should have a swear jar. I swear on this jar. Oh, there we go. Corrupt type information. Yes. Oh, why does everything have to crack all the time? Okay, where did the issue occur? Now we get to use our break, Rust Panic. So it's in here. There it is. Oh, I can't stress the importance of having a functioning debugger when you're working on something that's more complex than a sandwich, right? Okay. Nope. That did not work. State as maybe failed. Okay, so as maybe failed for... Yeah, that one's fine. That code's going to be thrown away now. So much stuff we can throw out. And this is the state storage. We don't care about that one. You know what? I'm changing the name of this thing. I don't care. fixed. Okay. Right, so resolving the value again. Here we go. So it's a maybe value, and it is a state. But why is this failing? I kind of want to see a bit more of this. There we go. Okay, so yeah, get on with it. Let's step into this one. So inner S state. Wow, we have gone deep into whatever this is. Oh my, okay. No, you didn't kick me out, did you? Why is that returning none? What am I doing wrong here? Do we... Yeah, okay, this is what I'm doing wrong. Right, I'm being an idiot. I'm being an idiot, don't tell anyone. Okay, let's try that again, shall we? Now we have something there. Oh, no, that's correct, because there is no value there. But one thing we're not doing is we're not getting notified of changes to the value. So the moment we add that in here, we're gonna be golden. So we are not going to nullify this one. We're gonna match on this. Here, we need to return null. But it's not as simple as that. I'm doing this in the wrong place, okay? Here, we're gonna match. This is gonna make this work, and it's gonna be beautiful. Damn, we don't have the context here. Hello, Bonin. How rare is which bug? Maybe not here. Maybe it's not here. Maybe we do this here. When can anything here ever be null? If it's a unit. But I still think it's fine to do it here. If it is null. Ooh, Nelly. No, because we have to do it there as well. Okay, let's find out where resolve pending is used. Here. Inside the index. Still inside the index. All right, then what are you crying about? Let's just chuck the context in there and be done with it. You need a lifetime, otherwise you're gonna get all cranky. What kind of psychopath formatter do we have? Yeah, that's not a... Is it not? Oh, component. Why is... Oh, shit. That's why. That's why. Yeah, I think we're good. No, still doesn't work. All right, we'll have to see to that then. Now the question is, will this work? So we go to resolve pending. If it's a maybe, then we resolve the inner value, which would be a different type. Yes. All right. So when I press a button, we're going to go through the event. We're going to set the value to 1, 2, 3. All right. Do I sound Welsh when I get angry? Okay, so let's try this then. It's working. Yeah. What about an if statement? If state.nullable. Oh, but we can't not that one. Ooh, that's interesting. Oh, we can't do that. Maybe. Yeah, so let's do that. Let's have nested ones, but that one is a problem. So what does it look like if we have a maybe? So now we are looking for a maybe, maybe. And let's do this in iterations, right? We can store a simple counter to know how many times we press the button, right? Okay, so state.counter. Come on. So we can see how many times we push the button. Then I have to run this at 10 frames per second. That was quite gross to see that. There you go. Now, we are going to say that this thing is maybe, maybe. So that's the first maybe that we get. Whoops. Then we want to take this maybe and say if none is maybe.get, right? That's there's no get on that. I didn't even remember the API for this thing. All right. If we don't have a maybe, then we do that and return. So the first 2 times we push a button, it's just going to do that, right? It's going to set this thing and then return here. This is insanely gross, Rust. Isn't this a maybe? Ah, right. That's a maybe. This is now the... Okay, and then we have to get the actual value of that. Like so. Okay. We have nested maybes, okay? Oh, what a journey, eh? What a journey. Okay. Wow, sorry, I have missed so much conversations. Okay. We don't have that anymore. All right, I need to make this work now. So where we have options, that should be a maybe. Maybe string default. Okay, so we need to implement default for maybe as well. Hello, Wire. How you doing? How you doing, buddy? We are definitely close now. Are you gonna join the relay, Wairu? Are you gonna join the stream relay? The maiden voyage. You sure did. What is the pin? It's a maybe string. Can we shortcut this one, maybe? But I'm not gonna be the first or the last, so it'll be perfect that you're in a different time zone than I am, because we're gonna keep the relay going for as long as we can, right? We haven't decided when it's gonna start yet, so it's very much up for grabs. Oh, really? But this isn't true. Oh, yeah, it is. I'm doing something dumb. It's going all right, Wine. How you doing? Oh, you need a type ID for that? Okay, we're gonna get rid of that one. Okay, there we go. So we have the means to clear this now. Wait, what? Why are they... Is there another take here? Where's the other one? 59. That's not a, that's a unique, right? Oh, value already has a take. Oh, damn. Kind of, right? So we haven't gone through the specifics for this year, but I'll show you what we had last year. Last year we had the code relay. You'd clone this repo and make a PR when you were done. One participant would start by creating a new project. No one knows what the project is supposed to do except the first participant. We're changing this a little bit this year though, right? But that probably becomes irrelevant soon enough. The participant works on the project live on stream for 3 hours, then commits the code and rates the next participant if they are streaming. The stream does not have to be on Twitch specifically. As a participant, you have 3 hours to make an assumption of what the code is supposed to do and start contributing. The spirit of the relay. This is supposed to be funny and entertaining. You don't have to be a 10x dev or a 1% to participate. It's okay to modify code committed by others before you, but try to keep the changes to others' code to a minimum if possible. The rules. There are more guidelines than rules, but try to keep within the spirit of the relay. No watching other participants that are on before you. We're scratching this rule because it's way too much fun to watch this. So this is we're ditching this one, right? Kiwi cross-platform, that's kind of a given maybe at this point. The code has to compile before the handover. We're keeping that one, but we're not keeping the zero dependencies. Instead, this is going to be specific for Anathema. So we're doing an alpha Anathema relay is what this is called. Stream for 3 hours, working on the code, then commit and push. You don't have to stream for 3 hours, but work on the code for up to 3 hours, right? So if you want to do it for 20 minutes and then you're like, I don't want to do this, then you can do so, right? Rate the next person in the line if they're streaming. Absolutely no comments in the code. Rustlang only, no build RS file for obvious reasons, right? So there was a few of us here. This became a really nonsensical YouTube video. Let me see if I can find the nonsensical relay video. This is all nonsense, right? From last year. It's very incoherent and such, right? It was good, and I enjoyed watching it, so I'm happy that we're scratching this rule because I don't want to go first this year. So we haven't decided who's going to go first, but we'll try to set up time slots like we did last time. It was good. You don't have to be a good programmer or anything. You just have to, you know, hack at it for a bit with a stick and see what comes out of it, and, you know, don't worry about it. This take function is different from the underlying one. I'm just gonna get rid of this one. But this works. What happened to it? Oh, it's there, but it didn't become anything, right? I started it and it ended up in whatever it was, right? But this year, since we're gonna let other people watch the predecessor, because you weren't allowed to watch the person before you streaming, so you had no idea what you were getting into. But that was mostly fun for me who started, and since I'm not starting this year and I thought that was really fun, I said that okay, this year whatever come, we will let everyone watch. We'll skip that rule for now. But it was really funny, right? It was a hot mess. I will try to get some more material out on how to use this, because this is the reason I'm doing this again. So I'm going to try to get more information out on how to use this and what have you. And now, obviously, I ran into another bug now, right? We can't do negative conditions, which sucks. We can look at, I know why, because if an if statement, you will evaluate a value to true or not true, specifically based on things like empty strings, empty lists, and null and what have you, right? Because this makes sense in a template, right? It makes sense to say if state.maybe, maybe, then show this. Right? It makes sense. But you might want to negate this, but that doesn't work. You can't negate this thing. Yes, so how is this implemented? It is implemented as a unary expression where the left-hand side translates into a not, and then we try to evaluate a Boolean value on the other end. But that means that it's only going to be Boolean values. So you would have to say something like not true versus not false, which will suddenly work. Because these are Boolean values, right? So where's the not in here? So this, we lifted this for... We lifted this truthiness check for... Fuck is it called now? Control flow for if statements, right? Or expression RS is so much better than what it was before Wairu. I think most people could probably wrangle their way through it. But it became, what was expression RS became a separate project called the value resolver. What we can do is we can just evolve it in the same truthiness, right? Yeah, it's changed. It's miles away from what it was. But I think we're almost there, right? There are some bugs, obviously, but I think we're good enough to run with this. I need to write some tests for this, and I got 17 warnings we're going to clear up, but in general, I think we're going to be good. So instead of resolving a value that becomes a Boolean value, what we could possibly do here, so there is a truthiness check here, right? That works on a value. So this thing works on the value kind. So we could add a truthiness check to the value kind instead. And what we get here is a value kind. So we can just do this, right? Let, whoops, value equals, and then here there will be value.truthiness, right? Like that. So we just have to implement this function on the value kind, and that's easy because we're just going to take this one that we have here, and then here we'll just say self.kind.truthiness, and we go in here match on self. What? Cycle detected. Why? That should be a bool. Holy bad error message. Okay. It's the future. Even MySQL supports JavaScript. So Anathema templates will never have a full scripting language. It's just for layouts. There are probably lots of TUI things for JavaScript. I know Python has a lot, so yeah, there is that. Are you joining this year, Londo? We need to get the conversation going on Discord. So if you're not on Discord, hop in on Discord. Join the channel called Anathema Alpha Relay. It is under challenges. No, it isn't. It's under programming. And we'll try to get a serious conversation in there at some point, right? But now I think I fixed it, right? So we should now be able to run this. It's not working. Oh, right. Sorry. Yeah, it's working now. So now we have negative, right? Okay, so let's fix the witch box. So then here, when I just take this, is that right? Why are you complaining about the color? What's the color here? It's an option hex. The wizard, Harry, is doing all right. Can we maybe make a maybe from an option? That would be a little bit more convenient, right? So let's go to maybe and let's implement t value maybe t. And then we have a... Actually, we can implement from option t for value maybe t, right? I think that will be pretty swish. We're going to match on the value. If the value is sum, then we're going to call self. No, we're going to call maybe some val into. If it's none, then we just do none into. I think that should be good. As long as we add some trait bounds to headers. Right, there we go. So now we can just make the... Okay, it just started working. Okay, magic. Oh, I love some tea. I haven't had a drink in 6.5 hours. I sounded like an alcoholic there. But, so that's a value maybe. Very much a teaholic. So we could set this to a maybe some message. That's a value. Why can't we take that? Because... No. Can't move out of pin, which is behind a mutable reference. All right. Okay, so that's running. Let's restart this. Streamer do need them breaks. You're not wrong. All right, so now we can pin messages here, which is cool. Okay, so then next up is going to be to implement timers and stuff. But, well, this has been a massive change, right? Ooh, we shall do something. I would love it if more people worked on this so I can start making videos and stuff, but I'm not comfortable with someone having to bear the burden that is the internals of this. It's very complicated, right? Oh, I still have some tea here, but it's clearly gone cold now. I've kind of done this already, Waru, but we can definitely do more things than this, right? There we go. It does. Emotional vampires. I try to say my terminal, right? Okay, let's commit this stuff now. Have we changed the MSRV for this? We don't have one. Okay, well, there you go then. We require 2024 at least. Ah! That was a lot of noise. Oh yeah, we can get rid of that now. Wow, look at all this code we get to throw away. Isn't that fun? Look at the code that we don't care for anymore. I want to do an Anathema jam as well at some point. But we need to get like a bigger audience for that, right? Like not audience viewing, but participating rather. Not audience then, right? We need to get big, like more participants for that, because I have some thoughts about what we can do for that. Okay. Oh, thank you, Upcasting. I think it'll be fun. But first, let's do the relay. See how that goes. Did you finish your video, Wairu? I like the part where your shirt only showed a little bit, says nobody loves you. Even though that wasn't intended, that still stuck with me. I'm gonna tell you guys about my dream. And no, I'm not punishing you, right? But I dreamt that I made a game and there was a really fun mechanic in the game, and I was going crazy this morning trying to remember what the mechanic was. So I'm not really telling you about my dreams, right? Do you love that when people are like, oh, let me tell you about my dream, man. I dreamt I was like a lizard that was also a unicorn and a seagull at the same time, and you were there, but you looked a little bit like a trait object. And you'd be like, buddy. All right. Good work. Oh, there's a panic in here for something called merge. Hmm. So it's probably the list then. Oh. Sorry, Christopher.
Mass is dying.
That was your alarm there, right? That's why. So we need to have a we need to do this. There we go. Oh. I'm so happy we got there in the end. All right, that one should probably not be called that. Okay. It's fine. Wow. So much work has gone into this now. And we have a new type. What's going on here? Resolve maybe. I think we can get rid of that one so we don't add that. We do have that now. Whoops. Maybe that should just be unreachable. Oh my god, how much do we have here? Really? Oof. Okay, there we go. There was something that was supposed to be unreachable in the resolver. This. Yeah, so the state cannot be a maybe value. Can it though? I don't think so. But that is not true. I think this is wrong, maybe. I think this is wrong. We should probably do something here. Because you could have a maybe value as your state. Right? let's go into demo and let's just say that we have a component here. We don't even have to do that. When we say the state is a maybe string, right? It's valid. OnlyFans. All right. When is dinner? I'm asking you. Since this is okay, that means that the state could be that. But then if we can do that, that means that we could have a composite one. Yeah, oh, beans. Whenever you cook or order it, there you go. Okay, so this is currently a to-do, right? Okay, so resolve maybe should probably go. Yeah. Yeah. Oof, okay, well, what a day. I can't believe we got there. I can't believe we bloody well got there. Okay. Yeah, now the question is, did we push this? I think I did. Yeah. Hello, Ergo. It's going all right. How you doing? Okay, that is working now. Yeah, I didn't think my Rust format was working. Okay, so we need to make this one a little bit better as well. But I can do that some other time. Wow, I'm so cooked now. I can't believe we're almost done. Okay, who's doing what? All right, we're gonna do a raid. I think we'll raid. Let's see if you are doing Rust. Are you doing Rust? Then we'll raid you. Otherwise, we're gonna raid someone else. You are doing what? What are you doing? No, not Rust today. So you don't get a raid. All right. All right, we're just gonna raid Prime today. Yes, do join the Discord. I will be back tomorrow, and maybe we can finally add the new event system, and that's gonna be great. It's been a good stream. What a roller coaster. You guys have been great. Thank you for hanging out. I will be back tomorrow with more ridiculous nonsense. You guys are wonderful. Have a great evening.